the final exam over momentum section that I'm not requiring to help study for tomorrow's test. I mean, there's on the final exam review, there's a momentum section that I'm not requiring. But if you're like, man, long time. Just throwing it out there.
Actually, no, there was extra credit.
Yeah, here we go.
I know it's awesome. It's like 6
So really, I got like
awake and I'm getting ready right now. So I'm good. I'm so, I love it.
that's so good.
Here we go.
She said that you have extra credit when you clearly got extra credit. Like, we just got like work.
The correct answer is correct answer is Crazy Cats. B. You remember when this used to be hard?
It still is hard.
Yeah.
How much you've grown?
I'll be downstairs.
I'll just take my phone.
Yeah, I'll be downstairs.
Yeah, but you'll be.
I'll meet you with
Correct answer is C. 9.8 meters per second squared downward. If you were tempted to say decreasing, then you're still getting velocity and acceleration confused. If velocity is how fast you're going, acceleration is how quickly that velocity is changing. Changing at a constant rate.
I forgot to.
Folks, if you're not paying attention, I'm fine with that. Just don't distract other people from trying to pay attention. Correct answer is C. They both experience the same change in velocity. The one that was thrown is obviously going faster, has a greater velocity, but the change in velocity is the same because they experience the same acceleration of free fall. So rounding 9.8 to 10, the drop one goes from 0 to 10 meters a second. The one that was thrown goes from like 15 meters a second to 25 meters a second. Both experience an increase of 10 meters a second. Correct answer is B. 1 meter a second downstream. Next. Correct answer is C.
Why, could you explain?
I sure can. So 4 meters per second, going that way. You're swimming this way, 3 meters per second. You want to find the resultant velocity. Please do not forget to cut and paste first, like don't do this, but then do this. Cut and paste. It's a 3, 4, 5 triangle. You're going to do Pythagorean theorem. Good. This is 3, this is 4, so 16 plus 9 is 25, square root of 25. 5. 3, 4, 5 triangle. You need a calculator on that one?
No, I'm not.
These things are the bad.
Do you always go off the x-axis? Yeah, I know, but I'm saying like what is the angle? And it's going to the x. Straight. I think.
Correct answer is A. This is the angle. So your x component, you're gonna use cosine. Y component, you're using sine. The negatives come from the fact that it's going to the left and downward.
So the vectors would just be on the line of that down?
Yep, the components. So this would be your x component of 4.53, and this would be your y component of 2.11.
Could you do it the other way?
Yeah, I got that. But it's mine's not negative, but it would be negative.
Could you do it the other way?
I always do it.
Down and to the side? It would be the same thing.
But you did, this angle would not be 25, this angle would be
Do the angle first, enter and then multiply.
55,
Yeah, that's what I usually do, but you don't have to do it that way.
65,
Because it's
65.
in big pieces, so it's. But like, that's how it looks when you write it out. Yeah.
Next question. Correct answer is C, the same time. This is the demonstration where we launch versus shot from the ceiling.
And then you whipped it completely.
Yes.
Lucky drop.
I don't understand.
But he's so new to it. It's becoming really
Okay.
No, I did. I did see that.
Correct answer is C is the only false one. A A and B are true.
What? How is that true?
A is true because it speeds up. So horizontally it stays constant, but vertically it speeds up.
Like C. No,
Okay? A and B are true, C is false.
like doesn't it slow down as it hits?
Doesn't hit the ground. In the free fall. Like we don't consider it after it's. Yeah. Like you never end it,
But
it's
even
only in
as it's
free
like,
fall.
even though it ends, it's like forward.
It's getting faster. Next question. The answer is A. The one that was closer to the ground. Be the same results as if you just dropped them from the second story and the third story. And your initial vertical velocity is 0. Good? Correct answer is A. There are no forces acting on it in the horizontal direction. It's going to do what inertia wants to do, which is maintain its velocity. A. That's why they move. The wind. Correct answer is B. Okay, the final velocity is not 0 because it's still moving. It's how fast it's going as it hits, not. Like it's not. Don't do that. Good? Correct answer is B. Okay. Remember, your horizontal velocity remains constant. There's no forces acting on it. Just gravity. Vertically, it's slowing down. Velocity at the top equals 0. And then it speeds back up. Okay? So, at the highest point, it's going the slowest, but it's still moving horizontal.
So like if you're doing it like not at an angle, VF will equal 0.
Yeah.
Yep. Good.
I know when you guys stop saying that. I say that every time I show Mr. Smiley, do you know what time of hour it is?
53.
Yeah, it's fine, it is what it is. I just sometimes like I'm 30 or 40 minutes late, so. I always forget, I normally text you at the beginning of the day, but I just forgot today. They're pretty chill about it, I just feel bad if I can't.
Correct answer is C. You're gonna do cosine of 60, which is 1/2 times 40 meters a second, which is 20 meters a second. So that. So the triangle of that. Here's 40. You're doing the cosine, which is 20, and theirs is still 20 meters per second.
How do you know to use
You're looking for the horizontal component, adjacent side.
Start setting. I started studying it, then it was like. There's the first 3 chapters. I don't There's no force in the blood, right? Is this the one I'm gonna get paid?
Correct answer is D, just the force of gravity. Next. Correct answer is C. Correct answer is A. Requires no additional force. That's just inertia doing what it's doing. Like, hey, buddy, let's keep doing. Correct answer is dangerous dinosaur. And that force is equal to, or divided by the mass. So force divided by mass gives you acceleration.
Are you gonna give us like that equation?
Okay. Correct answer is B. Constant velocity, you know the net force is equal to 0. It's going to do what it wants to do. Still in your hand. Correct answer is C. Your acceleration is upward, therefore the net force is equal. It has to be upward as well. After leaves your hand. Correct answer is A, just the force of gravity. This is while you're catching it. Correct answer is D, dangerous dinosaurs. The net force is not in the direction of motion, but in the direction of acceleration. Moving downward, but slowing down, therefore acceleration is in the opposite direction. So the net force has to be greater than the force of gravity. Okay, this final exam. Next time we'll take the test tomorrow, and I probably won't have the time to next time I'll see you after that is final exam.
What
No, just kidding. You're gonna have tons of time.
Yeah. You're saying it's a lot.
All right. I'll tell you about it.
What
Later.
is our final?
So your final, the multiple choice tests, I qualify them as medium to difficult multiple choice. The final exam is going to be what I would consider easy to medium, favoring concepts over math.
We still have that year period submitted period before we take the test like we did last year.
We're going straight in.
Yeah, I guess. Just don't like yeah. I'm actually gonna be so mad because I want to see it. And I want to see it.
Is it all multiple choice?
Yeah.
Oh. So it should be easier than the questions at least.
Well, if you had to take just the force part, like force test, and then a portion of the question that deal with force, you'd be like, oh, that was easy. But the fact that you're doing it so
Yeah.
Well,
But the questions are gonna be a heck of a lot easier than the test.
yeah. I want to say a heck of a lot easier.
But easier. And then how many questions are there?
I don't know.
You don't know yet? Is it gonna be over under 100?
Under definitely. Under 100.
Oh, yeah, so it's usually 150%. Oh! Mr. Smiley, sorry, can I borrow those cars again?
What are you borrowing?
Cars?
I don't really understand the answer. So this one, I just plug in the numbers and I really get when you do this. Or do you just put up this one thing?
I need it for my Spanish. Good.
Two
It's a
things.
Mustang or Ferrari.
Each other.
Dog.
Always experience the same, force. You can do it.
And then also, oh, D, I also didn't understand that one, because for that one, I got the mini. Yeah, I clicked random numbers and then I got it.
So you gotta be careful with random numbers. Because you can, in your choices at random, you can pick numbers that wouldn't cause that to happen.
Okay.
Does that make sense?
So how would I like think about that question without like having to do math? Cause like I don't,
Yeah, okay. So you've got the combine and you've got the Mini Cooper. And when they hit, okay, if they hit and stick and stay and go at rest, you know the momentum of this has to be equal to the momentum of that. They cancel out.
mm,
Does that make sense?
mm,
But the fact that it went through this, which object had more momentum initially?
the combine,
If it went like this,
then the mini went.
yeah. Does that make sense? Because you're looking at the after effect, you're like, okay, I know momentum has to be conserved. So if this happened, the total momentum is 0, even here, because they're going in opposite directions.
Okay.
Okay, but if they're doing this, you know, the total momentum of the system is this way, both afterwards and before. So this guy has to have more momentum. You okay with that?
And I don't. For number 6. I didn't understand why it was, like, if you're thinking of a system and you had to include like the Earth, you also have to include everything else, like the diving board and like why do you have to include other objects? Like I was just thinking, like my answer for that without like having to look at the answers would just be the Earth. I don't know.
The Earth and person. That, like everything on the Earth.
No, it said, or right here it said, oh, the diving board, the water, the Earth, and you. But I was just thinking it was just the Earth.
So it depends on, well, it needs to be you and the Earth. Is that, are you assuming that you is part of the system?
Yeah.
Okay. If it, after it leaves the diving board, then you can ignore the diving board. So I didn't really preface it, so if you considered it after you left the diving board, yes, always in free fall.
Okay.
If you looked at it while it's heading water, you can put water in the Earth as well, or jumping on the diving board.
Okay.
Kind of depends on when you say start and
Okay.
end. You're right with that.
And number 9, I don't understand like the force thing, like how you know when one experiences greater force.
So this isn't so much greater force problem question, it's which one experiences the greater change in momentum.
Oh, so the one that moved, the one that experienced greater change in momentum.
So what I'm looking at is the golf ball hits, oh, you're saying the golf ball versus bowling ball?
Yeah.
Okay. Sorry, let me retract that statement. It is a force question, but it's based off of Newton's third law, so it's the same force.
Because it's a collision.
Yeah.
and
It's the same force and it makes the same force for the same amount of time. They always experience the same change in momentum. Always.
Okay, so when it asks for force, just think of momentum. Because like, what's the difference?
So golf ball versus bowling ball. So foundationally, fundamentally, they'll experience the same force. Okay? And they experience that same force for the same amount of time. So the consequence to that, cause and effect, is they will both experience the same change in momentum. Not the amount of momentum, but the change in momentum.
Okay.
So that, I don't want you to like, just cling on to, force and momentum, they're the same thing, like, no. Like, the force causes a change in momentum, and in a collision, they'll both experience the same change in momentum.
Okay.
You with that? The distinction
Okay. I think that's it.
Okay, I like the questions. Good. Sophia, I'm proud of you. I appreciate the fight all the way through.
Thank you.
You're welcome.